This is Dr. R. Obulakonda Reddy, Department of CSC Cybersecurity. Now, today we'll discuss on system monitoring. So, system monitoring in sense, so in a high performance computing, once our intention is produce high performance in a cluster systems. So here cluster is nothing but a group of nodes. Nodes are indication to this one, node 1, node 2, like this, node 1, node 2, and so on up to n number of nodes. We have to group into our cluster. System monitoring in the sense, so hidden some errors are maybe happened at a particular node. For example, node 2. Hidden some of the errors are hidden. So we have to monitor properly the system failure chances. What are the chances to fail? Now we identify those things and effectively we have to working these proper nodes. So that is the intention of monitoring. Always you have to monitoring in a cluster systems. Cluster have a different group of nodes. Like this one rectangle is indication to node. This is a node. Node nothing but it is a group of nodes combined into a cluster. So the cluster once you have to monitoring. Always we should have monitoring the cluster systems which have some of the errors are hidden. So we have to identify those errors. So when it may be happen the errors, we have to preventing those errors. That will be given as a high performance. So that is the intention. Now here system monitoring, it is a vital to stay informed of any incidents that may cause unplanned downtime. So if it is not some of the errors, we are not incidents, any unwanted incidents happened at a nodes, we are not identified, the system may be down. So that has to be identified. That is the major thing. So always you have to monitoring, that has to be a unplanned downtime. Whatever the systems has to be suddenly happened some incidents, that may be the system may be down. Down in sense may be a shutdown. So that is the situation now. So our intermittent problems also are there. So some problems that trivially found in a single systems may be hidden for a long time. So some of the issues are, some of the incidents are not happen at a long time. That may be running in a system, but it may be a long time. That may be a found. So if it is monitoring always the node monitoring, that may be found. So what is the chances to down our systems? So we identify those things and take a proper actions. So now here they have to be detected. That is the very important thing. Long time they may be run internally. We have to identify those incidents, unwanted incidents. So that is the thing. Now here usable unsustainability of general purpose of monitoring tools. We have to use a proper monitoring tools. We have to unsustainability of a general purpose. Okay, general purpose of monitoring tools. Now main purpose is network monitoring. So network failures. So what type of network failures? These may be rises. Not the case with the cluster. So this is the thing. So main purpose is always we have to see that networking properly. The network is aligned the nodes. In between a nodes, the network properly we have aligned or not. Or there may be a chance maybe rises in a network problems. We have to identify monitoring and identify those network issues. And second thing is, this is obviously not the case with the clusters. The network is it is a component. The network is just in a cluster systems. The nodes network is taken for one of the system component. The component, even if a critical one, that has to be considered with a component only, a single component. Like our computer is to be connected with a CPU, a keyboard, mouse, some different part. Each one treated as a one component. Like each node is considered as in a cluster. Each node considered with a component here, system component. So, but the sole subject of monitoring itself. So that is the thing. The monitoring by itself. Every node has to be a monitoring. What type of, we have to write a particular program in that node. That has to be it has to be checking what type of problem arises. And automatically it has to be detected. Automatically detect and recover those errors. or unwanted incidents. For a damage of set down the systems. Whatever we have to down of the systems, identify those things, and then it has to be rectified. Rectified. That's the thing. So in the most cluster setups, it is possible to install custom agents. Custom agents in the nodes. So this is the custom agents. So that flexibility in each nodes. The cluster setup is possible to install custom agents in the nodes. So what are the track usage? What are the track you have to use in a node, and what is the load, particularly node. So each node in a cluster systems, like we have to draw like that. Each node, this box is indication as a node. Node means a systems has to be interacted with the clusters up to maybe 1,000, 10,000, whatever we are planning. We have to form with the clusters. That has to be checked with a track usage. So particularly, always itself has to be checked with what is the track usage, what is the presently we have used, what are the tasks we have to done here. So what actions you have to perform. Each system itself has to be checked. What is the load in a each system? We have to see that what is the load. It has to be executed in a nodes. And the network traffic. So in between node to node, what is the conjunction? You observe that what is the network traffic. It may be any latency there. Now we have to identify that. And tune operating systems also. And find IO, input output bottlenecks. And next is possible problem. First is possible problems. And then balance of feature system passages. So these are all the we have to identify in the cluster setups. Now subjects of monitoring. Why we are monitoring the nodes in a clusters. Now here physical environment. We have to create one physical environment in a nodes in a cluster. Now in the physical environment, that has to be a for monitoring. That is a very important subject. So that has to be, for example, if you take nodes, what is the presently temperature out? What is the humidity? What is the supply voltage? If it is a supply given node, that may be damage the components inside of a node. So we have to monitoring with what is the presently node temperature, what is the humidity, and what is the supply voltage to a particular node. Now see here the functional status of moving parts also. So moving parts of functional status that may be affected with a monitoring. So that is the thing. And next thing is some of the environmental variable stable. This is a very important. Keep some environmental variable stable. Some of the environmental variable you have to stable. Don't be moving. It has to be stable a particular place within the reasonable value. It may be greatly help keeping the high performance. Don't be always changes those things. If it changes, that may be a keep it some environmental variable has to be a stable within a pixel. So that will be produced with a high performance. If it changes, that may be a loss. So this is the subjects of monitoring. And the other thing is logical services. First one is a physical environment, and second thing is the logical services. So the logical services aim to finding current problem when they are already impacting the system. So finding the current problems. Logical services aim to finding a current problems. What are the present problem existed in it, and when they are already impacting the system. So now we have to see here low delay until the problem is detected. So a low delay until the problem is detected, and isolated must be a priority. So individually run a system that has to be given as a high priority. And next thing is a find error or misconfigurations. So logical services that has to be find error and misconfigurations. And next thing is a logical service ranges. What is the range for a logical services? Now it has to be focused on two things: low level, high level. So low level will access with a low level will focus on the network access and running processes. So that has to be pointed with a network accesses and running processes. And high level that will be focused with a RPC, remote procedure calls, and NFS services running and the correct routing. So this is the logical services ranges will focus to a low level, high level. Like a low level will network access and the processor running. High level will see that RPC, remote procedure calls, and NFS services running, and correct routing. Properly we have to deliver with a packets or not. Routing will be properly aligned or not. Then we use for that all monitoring tools provide some way of defining customized scripts for testing individual services, like connecting to the telnet port of a server and receiving the login. Receiving the login prompt is not is enough to ensure the user to login. Bad NFS modes would case they login. Skip to sleep servers, sleep forever. Now other thing is performance meters. So the performance meters will tend to be a completely, it has to be a application specific. These performance meters has to be specific for a one particular applications. So it has to be focused on two things: code profiling, that has to be a side effect, time and cache memories. That has to be a side effect with a time and cache, and spy node. For it has to be maintained with a for network load balance. Spy node has to be maintained for network load balance. Now special care must be taken when tracing event that spans several nodes. So it is very difficult to guarantee a good enough cluster-wide synchronizations. Difficult to guarantee good enough cluster-wide synchronizations. So this is the subjects of monitoring with a performance meters. Now see here, the thing is self-diagnosis and the automatic corrective procedures. Self-diagnosis. Itself, the system has to be check itself diagnosis. What are the problems we'll get it in a features. So that is the self-diagnosis. And whenever the problem maybe rises in a long time, that has to be rectified and it has to be solved. Now taking a correctiveness measures, taking corrective measures. So in features, what are the problems maybe rises. So taking a corrective measures. And the second thing is making the system take this decision itself. The system has to be take the decision itself. So we have to develop in a node, for example, node. We have to write one of the software inside of that. That has to be a monitoring purpose. I'm talking about that monitoring purpose. We have to write one software, internal software that has to be check itself. That should be a taking corrective measures and take a decisions. Some problems maybe rises. That has to be itself take a decision, rule based. Now see here, taking automatic preventive measures. So these are all the three important things. Taking corrective measures. The software has to be should be take with a correct measures. A correct measurement. Through those measurements, we have to identify the problems. And second thing is, once the problem is rises, you have to take a decision. Once this is a problem, so we have to take this solution. This is a solution to this problem. Itself has to be take a decision. And taking automatic, the procedure has to be taken with preventive, automatic preventive measures. So maybe rises in a feature that may be rises. So automatically we have to prevent measures has to be taken. And next thing is, in order to take reasonable decisions, the system itself has to be taken with a reasonable decisions. The system should know what sets of symptom lead to a suspect of what failures. This is the important thing. So the system should know, the system itself know what set of symptoms lead to suspect of what failures. So this is a symptoms, like a set of symptoms, like a 1, 2, 3 symptoms that may be lead to a network failures, or 4, 5, 6. This is a symptoms that may be a problem with a routings. Something it has to be a routing issues or network failures, or system may be set down. Some issues we have to suspect it. So system should know that what set of symptoms leads to suspect of what failures and appropriate corrective measures to take. So this is the main thing that should be focused on a monitoring of a nodes in a cluster system. Now, and second thing is performing automatic correction should be at least based on a rule-based system. That should be taken for a rule-based system and not rely on different alert action relations. Not rely on direct alert action relations. So this is the talk about that. This is talk about that self-diagnosis and automatic corrective procedures. Now, previously we have to talk about this. We have to monitoring a systems. Monitoring, always keep on monitoring. The system itself has to be a monitoring. That has to be rectified. In a features, maybe suspecting some of issues. That will be corrected. That will be find out and corrected. Now it is a system tuning. Next is the, after monitoring, we have to see the tuning. Tuning is nothing but we have to set a one goal. I want a particular node has to be produced with a high performance computing. Now I want to require for a, the system has to be produced with high performance computing. The node, particular node has to be produced with high performance computing. Now we have to set with a goal. So that is the tuning. Tuning is before tuning of a node, we have to set the goal. What is the goal? High throughput or high performance. Throughput is nothing but finally it has to produce with a high performance. The node has to be given as with a high performance computing. So initially we have to set with a goal. That is the thing. So now here system tuning, that has to be produced with a, initially we have to set with a goal. So no tuning can be done without a defining goal. That is the major thing. So now here tuning system can be minimizing a cost function. And second thing is it has to be a minimizing the cost functions. Like we have to take with a higher throughput for job, may not be help for increased networks. If it is produced with a throughput for a job, not be help for increases network. And second thing is no performance gain comes for free. And often means trade-off. Now performance, safety, generality, interoperability. These are all the things with the no performance gain comes for free. So tuning is nothing but it has to be set with a goal. Based on the goal, the node has to be tuned in the proper. Now focusing on throughput. Now focusing on throughput or focusing on latency. Latency means it's a delay in between the nodes that may be happen with a delay. Throughput means number of their jobs has to be completed with a particular seconds. Now throughputs. If it is increased with a throughputs, that has to be automatically that will be reflected with a high performance. Now see here, in most Unix systems, tune for high throughputs. Most of the Unix systems we have to focus with a higher throughputs. Each and every Unix of the operating systems of a node that should be produced with a higher throughputs. So it has to be for general time saving systems. And the next thing is clusters are frequently used for large single user systems. Clusters are frequently used. Total clusters has to be taken for a, it is a large single user systems. Every command like a total, that command has to be worked with a single command has to be worked with a total clusters. It is taken with a large single user system. And what are the main bottleneck is latency, means delay. The main thing is in between the cluster to cluster we have to send some of the data, or we have to perform with a particular task. It has to be a bottleneck. Bottleneck is the main issue is the latency. Latency means it has to be a delay. Now see here, network latency tends to be especially critical for most applications, but hardware dependent. It has to be dependent on hardware, but latency tends to be especially critical for most applications, and but hardware dependence. Lightweight protocol do somewhat, but the currently highly optimized IP stack, there is no a huge difference in most hardware. Now see, each node can be considered as just components. So each node in a cluster considered as a component of the whole cluster, and it is to be tuned for global performance. So each node has to be considered with a component. The component should be produced with a high performance. So it has to be tuned and it has to be performed with a global performance. Globally performed with a high performance. Next thing is the caching strategies. There is only one important difference between conventional multiprocessor and clusters. So mainly that has to be seen that memory. So what is the conventional multiprocessor and clusters? Whole cluster in a clusters it have a different node that totally considered with a it has to be considered with a single systems, single largest system in a cluster. The group of nodes has to be connected. That whole system is considered as a large number of nodes is connected, that is called as the clusters. Multiprocessor means the memory may be, see here, next slide we have to see that is the thing, the in a shared memory. So each and every CPU has to maintain with a single. But in a distributed shared memory, each and every CPU has its own memory. The first one is memory has to be shared. A single memory has to be shared with the CPUs. But in the second case, distributed in the sense distributed environment, each and every CPU has to maintain its memory. Now, this is the thing. Availability of shared memory. That major focus on availability of a shared memory in between the conventional multiprocessor and the cluster system. The major difference is the availability of a shared memory. The only factor that cannot be hidden is the completely different memory hierarchy. The only factor that cannot be hidden is the completely different memory hierarchy. So now data caching strategies may often have to be inverted. Now see here, local disk is just a slower persistent device for a large term storage. You have to use local disk for just for a slower and persistent device for a long term storage. And next thing is faster rates can be obtained from concurrent access to the other nodes. That has to be focused on wasting other nodes resources. Another thing is saturated the cluster with overload nodes may perform worse. So it is a saturated cluster. This is the thing. And next thing is getting a data block from the network can provide both lower latency and higher throughput than from the local disk. So this is a things we have to observe that caching strategies. Now see here memory. In a memory, shared memory versus distributed memory. So this has to be depend with a shared memory. Every taking group of CPUs has to be shared with a single memory. Single memory has to be shared. At a time it has to be greater than 250 MB. Greater than 250 MB, that has to be taking the each and every CPU. Greater than 250 MB. In a distributed environment, here that may be taken, the LAN connection that may be taking the data transfer to 10 to 100 MB. So now in a memory, that always it has to be taken with a 10 to 100 MB. Now 10 to 100 MB, and now this is a greater than 250 MB. So this is the major. So here the difference we observe that a single memory can share with all CPUs. Is the memory is the one. This has to be shared with all CPUs. Now here, coming to the distributed environment, each and every CPU has its own memory. So that is the concept. That is the thing. Shared versus distributed memory. So these concepts that has to be a differentiate with a conventional multiprocessor and clusters. And fine tuning the operating system. Next thing is the tuning. In a tuning operating system also, that has to be produced with a high throughput. So virtual memory subsystem tuning. So one thing is VM subsystem tuning. Other thing is a networking. You have to tuning the two things: VM subsystem tuning and the networking. So virtual machine tuning, that has to be optimization depend on the applications. But large jobs often benefit from some virtual machine tuning. So most of the jobs has to be get a benefit from virtual machine tuning. Optimization depend on the application. So based on the applications, the large jobs often benefit from some virtual machine tuning. You have to tune some applications that has to most of the jobs has to be benefited in a virtual memory subsystem tuning. Second thing is highly tuned code will fit the available memory. So now we have to write a highly tuned code will fit the available memory. Based on that available memory, we have to write a highly tuned code. Next thing is tuning the virtual subsystem has been traditional for large systems. And large system as traditional Fortran code used to over commitment memory in a huge way. So this is the points we discuss about that VM subsystem. And next thing is network tuning. The network tuning in sense when the application is communication limited. So most of the application that may be a communication limited, and then that has to be a bulk data transfer that has to be transferred in bulk data is transferred, increasing the TCP UDP receive buffers, and a large windows and Windows scale. Large windows and Windows scale. Next thing is inside clusters. So inside clusters, limiting the retransmission times. Once the failure of a particular data, again it has to be a retransmission. That has to be a timeouts. So limiting the retransmission timeouts, and switches tends to have a large buffers, and can generate important delay under the heavy conjunction. Delays under the heavy conjunction. During heavy conjunctions, so generate important delays under heavy conjunctions. So this is the thing about that system, operating system tune. Now I take the references from these textbooks. High performance cluster computing, architecture of systems, volume 1 by Booyah. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.